Okay, so in this video, we're going to talk about lipids and understand their properties and characteristics as well as what their uses are in our lives. So when we talk about lipids, there's certain characteristics that are true regardless of the type of lipid. So one of them is that they have this waxy, greasy, or oily consistency. And so basically what that means is like if you've touched like butter or something, how it leaves like a greasy feeling on your hands, that is a lipid. Or if you've touched oil, or you've seen bacon grease, those are all, or like wax, any of that is characteristic of lipids. And so lipids, they actually do not mix well with water, and they will repel water if they ever come in contact. So you can think about if you've ever like washed a pan from cooking bacon. If you use just water, the grease won't wash off. You actually have to use soap. So let's go ahead and see how this matters in life and look at some functions of fats and lipids. Now, one of them is the waterproofing aspect. So that green shiny part on leaves is actually like a waxy cuticle that plants will use to prevent water from evaporating too quickly from this plant. Now, ducks, they actually will, when you see a duck like biting its tail feathers, it's not actually like itching itself, even though that's what it looks like. There's actually an oil gland at the base of the duck's tail, and so it's getting like oil on its beak. So when it like bites its feathers is what it looks like. It's actually spreading the oil all over its feathers. So when it dives underwater, those outer feathers are waterproof. And so now the feathers inside, underneath, never actually get wet. And that is how a bird or a duck can help to keep its body temperature warm even when it's diving under cold water. Now we can also use our lipids for insulation. So you have the animals that live in the Arctic, for example. Oftentimes you're going to see lots of blubber, and that's used to help keep some warmth in. We could also use it for padding. If you think about humans, we store some of our fat around our midsection. We have our kidneys and our intestines there, so that fat can actually act as a little bit of a cushion. And then for humans or in animals, we also use our lipids for long-term energy storage. So when I look at this long-term energy storage, when we eat, let me move this up a little bit. So when we eat lipids and we want to store some, when we eat carbohydrates, for example, when we eat carbs, I wonder if I can move this higher. Okay. So when we eat carbohydrates, that is energy for us. And the carbohydrates, glucose, starches, are made of C, H, and O. And when we eat those carbs, the carbs are energy for us. But sometimes we eat more energy, more carbohydrates than we're actually going to use. In that situation, our body will actually take that extra energy, the C, H, and O, and convert it and turn it into lipids where we can store it for long-term energy use. So now those lipids is basically energy that we can carry with us for years. Okay, so let's go ahead and see some different types of lipids that we have. Let's see if I can move this back down. So when we look at when we look at, I don't know, the three types of lipids that we find on Earth, one of them, the majority of lipids on Earth are triglycerides. So we'll look at triglycerides on the next slide. And then in a whole different topic, unit, we'll talk about our cell membranes. So our cell membranes, all of our cells are actually surrounded in phospholipids. And that's like our barrier around each and every one of our cells. And then we have our steroid hormones. So lipids make up our testosterone, our estrogen, our cortisol, our stress hormones. And so when we look at lipids in life, incredibly important to our cell membranes, as well as our hormones and our ballates. And lipids are a great molecule for this long-term energy storage as well. So let's go ahead and talk about a triglyceride in a bit more detail. So a triglyceride has like two kinds of building blocks. We have the glycerol, and then attached to that glycerol, we have some fatty acids. And the tri stands for 3, so here we have 1 glycerol and 3 fatty acids attached. So here is the molecular structure. You have your glycerol, fatty acid number 1, fatty acid number 2, and fatty acid number 3. So when I look at fatty acids, though, they actually come in two kinds. We have saturated fatty acids, and when you look at the saturated fatty acid, you can see how it's full of hydrogens. You cannot fit any more hydrogens attached to that carbon chain. And then we have unsaturated fatty acids. And here you can see how that saturated is actually has what's called a double bond in green right here. And that double bond gives it like a kink or a bend in the fatty acid. So when we see, well, why does this matter in our lives? Well, you have what's called good fats and bad fats. And our bad fats in our diet are saturated fats. You can see that their 3 fatty acids are all straight chains, so they can pack really closely together. And then you have your unsaturated fatty acids, and those are going to be what make up your oils. So saturated are going to be like solid at room temperature, like butter or lard or Crisco, or even bacon grease that's gone in the fridge and like hardened. And then you have your unsaturated. Those are your healthy fats. Those are your oils that stay liquid at room temperature. So you have bad fats, which are saturated, and you have good fats, which are liquid at room temperature. So when I look at this, I can see in this triglyceride, I want you to take a minute and I want you to look and see like what kind of elements do you see in this triglyceride? Yes, carbon, hydrogen, and oxygen. Now, what could a plant use to build a triglyceride? Right? So if a plant is doing like photosynthesis, it has carbon dioxide and water accessible to rearrange that carbon, hydrogen, and oxygen from the air and the water, the CO2 and the H2O, in order to rearrange them and build lipids. So when we look at the 4 macromolecules on Earth, carbohydrates, lipids, proteins, and nucleic acids, they are made of 5 major elements, C, H, O, N, and P. So here carbohydrates are made of C, H, and O from carbon dioxide and water. Lipids are made of C, H, and O from carbon dioxide and water. Proteins we saw in class are made of C, H, and O from carbon dioxide and water, but also nitrogen. They got nitrogen. The plants took nitrogen up from the soil. And then our last macromolecule we have yet to learn are nucleic acids, where they have C, H, and O from the air and the water, carbon dioxide and water, but they also take up nitrogen and phosphorus from the soil. So when we look at all life on Earth, the 4 macromolecules are built from carbon dioxide and water by plants. And then the plants, in order to build proteins and nucleic acids, can take nitrogen and phosphorus up from the soil as nutrients to build our proteins and nucleic acids.